Right now, sitting in an archive at NASA, there's a measurement from the James Webb Space Telescope that no scientist on Earth can fully explain. It's not a glitch, it's not a rumor, it's a real signal, confirmed, rechecked, and still sitting there unexplained on two separate worlds, 4 billion miles apart from each other. One of the researchers who found it put it about as plainly as a scientist ever puts anything. He said, "It's rather mysterious." He said, quote, "We cannot say what it is." That's not the kind of thing a scientist says lightly. And by the time this video is over, you're going to understand exactly why this specific gap in the data has planetary scientists genuinely stumped, why it's showing up on two worlds that have almost nothing in common, and why the honest answer right now in August of 2026 is that nobody knows. Let's start at the beginning, because the way this was actually found is almost as interesting as what was found. Earlier this year, a team of researchers was working through James Webb data on Saturn's giant moon Titan, hunting through a narrow stretch of the infrared spectrum that most previous studies had simply skipped over. Buried inside that overlooked slice of light, they found something odd. A very specific, very clean gap, sitting at almost exactly 5.11 micrometers, a wavelength that didn't match anything in the reference libraries scientists normally use to identify chemical signatures. Here's the detail that turned a strange footnote into a real mystery. One of the study's co-authors, planetary scientist Bruno Bazar, turned to a colleague working on a completely separate set of Webb data, this time from Pluto, and asked a simple question. "Do you also have a signature at this exact wavelength?" They checked. It was there. Not a similar signal. Not a rough match. The same wavelength on a completely different world, 4 billion miles farther from the Sun, sitting in data collected by the exact same telescope. That's the moment this stopped being a curiosity and became a real scientific puzzle. Two worlds, enormous distance between them, almost nothing physically alike, and somehow both of them are carrying the exact same unexplained fingerprint. Before we go further, it's worth understanding exactly how a discovery like this even works, because it changes how seriously you should take it. Every single molecule in the universe absorbs light at very specific, very predictable wavelengths. It's essentially a signature unique to that substance, the same way a fingerprint is unique to a person. Astronomers read those signatures constantly. It's how we know what's inside the atmospheres of planets orbiting other stars, trillions of miles away, without ever sending a probe anywhere near them. So, when researchers pointed Webb's instruments at Titan and Pluto and looked for the specific wavelength gap that would tell them a known molecule was present, they didn't get a normal answer. They got a gap that didn't match anything. Not one entry in any published dataset at that exact location. The team went back and checked their work carefully. According to the study, uploaded to the preprint server ARCIV in June of 2026, they wrote plainly that they did not find any band referenced in existing publications that corresponds to the location of the observed absorption in Titan and Pluto. In plain English, they checked everywhere a scientist would normally check and came up empty. Now, let's actually talk about these two worlds, because understanding just how different they are is the whole reason this discovery is so strange. Titan is Saturn's largest moon, and it's genuinely massive, bigger than the planet Mercury. It has a thick, hazy orange-tinted atmosphere. It has actual weather. It has rivers, lakes, and seas made of liquid methane and ethane, making it the only other place in the entire solar system, besides Earth, known to have stable liquid sitting on its surface right now. Pluto is almost the opposite of that in every measurable way. It's roughly half of Titan's size. Its surface pressure sits somewhere between 100,000 and 150,000 times lower than Titan's, meaning its atmosphere is almost nothing by comparison. A whisper-thin haze instead of a genuine sky. Nothing flows on Pluto. Nothing pools. Surface temperatures drop below minus 370 degrees Fahrenheit. Cold enough that nitrogen itself, the same gas that makes up most of the air in your lungs right now, freezes solid onto the ground. One world with lakes and weather, one world so cold that air becomes ice, and somehow they're both carrying the exact same unidentified chemical signature. So what do these two very different worlds actually have in common? It turns out more than you'd expect, at least in one specific way. Both atmospheres are dominated by the same two ingredients, nitrogen and methane. And when sunlight hits that mixture high above either surface, it triggers a cascade of chemical reactions. Ultraviolet light breaks methane molecules apart into fragments. Those fragments recombine into heavier, more complex organic compounds. And eventually, some of that material condenses and falls, almost like a strange kind of chemical snow drifting down out of the sky and settling onto the ground below. That's very likely where this mystery signature is coming from. Not something buried underground, not something delivered from outside, but something manufactured directly in the atmosphere of each world, through a process that has apparently been running quietly and continuously for more than 4 billion years. Researchers were careful to rule out one possibility early on. This isn't a gas floating in the sky. When they compared the signal at the center of each world's visible disk against the signal near the edges, where sunlight has to pass through more atmosphere to reach Webb's instruments, they found the opposite pattern of what an atmospheric gas should produce. The signal was actually weaker near the edges. That told them this material isn't suspended in the air. It's sitting directly on the surface, coating the ground itself. And once they measured how strong that surface signature was on each world, they found the two didn't match at all. On Pluto, the signal came in roughly 3 times thicker than on Titan. Whatever this substance is, it's considerably more concentrated on Pluto's surface than on Titan's. On Titan, meanwhile, the material wasn't distributed evenly at all. It showed up more strongly on the Moon's trailing hemisphere, the side that faces away from the direction Titan moves as it orbits Saturn, then on the leading hemisphere facing forward into its own path. That kind of lopsided pattern usually points toward some specific, ongoing process actively shaping how the material builds up. Something tied to Titan's orbit, its exposure to radiation, or interactions with Saturn's surrounding environment that researchers haven't fully worked out yet. So now you've got a substance that's chemically unidentified, distributed unevenly, present in wildly different concentrations, on 2 worlds that shouldn't have much reason to share anything at all. That's the puzzle sitting on the table right now. Let's talk about what it might actually be. Because the researchers didn't just throw up their hands, they went looking for candidates. The strongest lead right now points toward a family of organic compounds called alkenes. According to the study, alkenes are essentially the only known organic compounds that produce a strong absorption signature in this exact part of the infrared spectrum, right around the 5 micron range where this mystery signal sits. That makes them the leading suspect, at least structurally. But even that answer isn't clean. The researchers noted that alkenes alone might not fully explain what they're seeing, and that the real answer could involve alkenes mixed together with other substances, possibly benzene, possibly a compound called ketone, and less likely, though not ruled out entirely, some form of acetylene ice. Here's the honest, unglamorous truth sitting underneath all of that. Nobody currently has enough information to say which of these candidates, if any, is actually correct. The study itself states plainly that the lack of onboard infrared spectroscopy capable of directly observing this specific spectral feature in surface materials prevents any direct confirmation right now. Translation, in plain language, we can see that something is there. We have strong suspicions about the kind of chemistry involved, but we cannot currently reach out and confirm it directly. That's exactly why one of the researchers described this discovery the way he did. It's rather mysterious. We cannot say what it is. Not because the science is sloppy, but because the science is being honest about the actual limits of what we can measure from 4 billion miles away. Now, I want to address something directly, because it's the question that's almost certainly forming in your head right now, and if a video doesn't answer it honestly, that video isn't being straight with you. Is this a sign of life? The researchers addressed this directly, and the answer is no. There is currently no evidence that this mystery molecule is any kind of biosignature. What it most likely represents instead is a form of prebiotic chemistry, meaning the kind of raw, complex organic chemistry that can happen naturally, without life being involved at all, but that shares some basic ingredients with the chemistry that may have eventually helped life get started somewhere, at some point, under the right conditions. Titan in particular has been running this exact kind of chemistry, undisturbed, in a completely oxygen-free environment for more than 4 billion years. That makes it one of the most valuable natural laboratories in the entire solar system for studying the raw material of organic chemistry, the kind of slow, patient chemical experimentation that on Earth eventually got interrupted, redirected, and ultimately swept up into biology. On Titan, and apparently on Pluto too, that early stage chemistry has just kept going quietly for billions of years, with nothing to disturb it. So no, this isn't a message. It isn't a biosignature. It isn't evidence of anything built or alive, but it is a real confirmed gap in our chemical knowledge of 2 worlds we thought we already understood reasonably well, and that, on its own, is worth taking seriously. Let's talk for a moment about why Pluto, specifically, keeps doing this to us, because this isn't the first time this small, distant world has forced scientists to rewrite what they thought they knew. Pluto was discovered in 1930 by a 24-year-old research assistant named Clyde Tombaugh, working at an observatory outside Flagstaff, Arizona, comparing photographic plates of the night sky night after night until he spotted a single point of light that had shifted position. For most of the 20th century, it was celebrated as the 9th planet in our solar system. Then, in 2006, the International Astronomical Union formally reclassified it as a dwarf planet, and a lot of the public quietly filed it away as demoted, small, and unimportant. That assumption did not survive contact with real data. In July of 2015, after a 9.5-year journey across billions of miles of empty space, NASA's New Horizons spacecraft flew past Pluto at more than 30,000 miles an hour. with exactly one chance to gather everything it possibly could in a matter of minutes before continuing on into the darkness of the Kuiper Belt forever. What it sent back rewired what scientists thought they knew. A massive, pale, heart-shaped plain, smooth and strangely young-looking. Mountains built from solid water ice rising more than 10,000 feet into a thin, hazy sky. And layer after layer of pale blue haze rising hundreds of miles above the surface, far higher and more intricate than anyone had predicted. That haze turned out to matter more than anyone expected. In 2017, planetary scientist Xi Jiang proposed something that sounded backwards at the time. That Pluto's haze wasn't warming the atmosphere the way similar haze does on Titan, but actively cooling it, absorbing sunlight and radiating that energy straight back out into space faster than Pluto's paper-thin atmosphere could ever hold onto it. There was no instrument sensitive enough to test that idea for years because Pluto sits so close to its large moon Charon in the sky that separating their individual heat signatures was essentially impossible. Then Webb arrived, and in 2025, researchers finally confirmed Zhang's prediction directly. Pluto's atmosphere really is being cooled by its own haze, sitting roughly 30 degrees Fahrenheit colder than older models expected. Scientists now describe it as a genuinely new kind of climate, unlike anything else we've found anywhere else in the solar system. That same haze process feeds directly into another strange relationship, this time between Pluto and its largest moon. Roughly 2.5% of the methane leaking out of Pluto's thin atmosphere drifts across the gap separating the two worlds and gets captured by Charon's gravity, freezing onto its polar surface during the decades-long stretches when that pole sits in total darkness. When sunlight eventually returns, radiation breaks that frozen material apart and reassembles it into the deep reddish stain that colors Charon's poles today. Nowhere else in the solar system do we see two worlds locked in a slow, ongoing chemical handoff quite like that. So by the time this new mystery signature turned up in 2026, Pluto had already spent a decade proving it was nowhere near the dead, frozen, leftover people once assumed it was. It has its own active, self-cooling climate. It's been quietly bleeding atmosphere onto its own moon for billions of years. And now, layered on top of all of that, its surface is coated in a chemical signature nobody on Earth can currently name. I want to be precise about one more thing, because a lot of headlines are framing this moment slightly differently than what actually happened. And getting this right matters if you actually want to understand the story instead of just feeling something about it. Webb has been observing Pluto steadily since 2022, checking in every few months as the dwarf planet drifts through its field of view. This wasn't some brand new, first ever glimpse at the planet. What actually happened is that researchers went back through existing archived data, some of it collected as far back as May of 2023, and finally looked carefully at a narrow slice of the spectrum that nobody had prioritized before. The signal had been sitting there, unnoticed, inside data we already had for roughly 3 years. That, if anything, makes this more impressive, not less. It means the answer to a genuine mystery was hiding in plain sight inside an archive scientists already had access to, waiting for the right person to ask the right question of it. So where does this actually go from here? Because a mystery without a path forward is just trivia. This one has a real path, even if it's a slow one. The research team has already secured additional Webb observation time specifically to follow up on this signature, according to reporting on the study. That means more data is coming, not years from now, but as part of an active, ongoing effort to nail down exactly what this material is and how it behaves. There's also a longer-term answer already on the calendar. NASA's Dragonfly mission is scheduled to launch no earlier than 2028. And if everything proceeds as planned, it will actually fly through Titan's atmosphere and land on its surface in 2034. Dragonfly isn't a flyby. It's a nuclear-powered, helicopter-style vehicle designed to hop across Titan's surface and sample material directly, carrying an onboard spectrograph built specifically to identify exactly this kind of chemical signature. If Dragonfly manages to identify whatever is producing the signal on Titan, researchers believe that answer would very likely apply to Pluto as well, given how closely the two signatures match, even accounting for their different intensities and different surface distributions. But that mission doesn't launch for at least 2 more years, and it won't actually reach Titan's surface until the 2030s, which means, for now, this stays exactly what it honestly is: a confirmed, real, carefully verified gap in our understanding. Not a hoax, not a cover-up, not evidence of anything hidden from the public. Just an open scientific question sitting on the surface of 2 worlds at once, waiting for better instruments to finally close it. There's something worth sitting with here because I think it's easy to rush past the actual scale of what this represents. We have a telescope sitting roughly 1 million miles from Earth, reading the chemical fingerprint of surfaces on 2 separate worlds, using nothing but the light bouncing off them. No physical sample, no spacecraft on the ground, just light broken apart into its individual wavelengths, revealing information about chemistry happening 4 billion miles away. And using that exact method, it found something that doesn't match a single known substance in any reference library humanity has ever built. That's not a small thing to sit with. Every molecule we've ever identified, in every corner of the universe we've ever studied, in every planet orbiting every star we've ever pointed an instrument toward, none of it matches this. And it's showing up not on one world, but on two, worlds that otherwise share almost nothing in common except the basic ingredients drifting through their thin, cold skies. If this substance really does turn out to belong to the alene family, or some mixture involving benzene or ketene, it would represent an entirely new category of chemistry actively operating on two different worlds in our own solar system. Chemistry we've simply never had the instruments sensitive enough to detect before now. And if it turns out to be something else entirely, something not currently on anyone's list of candidates, that would be an even bigger deal, a genuinely new class of naturally occurring compound, discovered not in a lab on Earth, but on the frozen surface of a dwarf planet at the edge of our solar system. Either way, the takeaway is the same. We built an instrument good enough to notice something we don't understand. That's rare. Most of the time, our tools tell us more about things we already expected to find. This time, Webb handed researchers a genuine blank space on the map, and had the honesty, through the people running the analysis, to say so plainly instead of forcing a confident answer where none currently exists. Here's what to actually watch for going forward, because this story is nowhere near finished. Watch for the peer review process. Right now, the study lives on a preprint server, meaning it's public and available, but hasn't yet gone through the full process of independent scientists checking the methodology before it's formally published. That process matters, and it typically sharpens or narrows down candidate explanations rather than overturning the core finding. Watch for the follow-up Webb observations the team has already secured. Additional data could help determine whether this signature strengthens the case for Allen specifically, points toward one of the alternative candidates, or opens up entirely new possibilities nobody has proposed yet. And if you want the longer horizon, watch for Dragonfly. A mission already funded, already scheduled, already carrying an instrument built to answer exactly this kind of question, set to land on Titan in 2034, with the potential to finally close the loop on what's sitting on the surface of both these worlds. Until then, here's where things honestly stand. Two worlds, separated by billions of miles of freezing, mostly empty space, sharing a single chemical fingerprint that no scientist on Earth can currently identify. Confirmed by careful, transparent research. Explained by nobody, not yet. That's not a conspiracy. That's not a secret. That's science working exactly the way it's supposed to, finding the edge of what we know, and being honest enough to admit it's still out there. If stories like this, built on real, verifiable research instead of exaggerated claims, are what you come here for, subscribe and turn on notifications, because Webb is still watching both of these worlds right now, and there's a real chance the next batch of data brings us closer to finally naming whatever this is. Drop a comment with your own guess at what the mystery molecule might turn out to be. Thanks for watching.